Okay, peeps. So, question 5. Now, lots of A's and B's and symbols and not many numbers in this question, so things can get a little bit confusing. They're saying with this first one, why is it that if you integrated from A to A, that your answer is 0? And really, explain graphically is really the way to go here. I'm just going to put in some function. I don't know, let's do this. There's some function, and there's a value, A, and I want to integrate from A to A. What happens? Well, I can get a height at point A, but what's the width of this rectangle? Right? The width would be A minus A. Right? There is no width, it's 0. And if I was to try and find areas, I'm saying length times width, well, it's times 0. The answer's just 0, right? Area equals 0. And that's pretty much all there is to that one. I guess you could use fundamental theorem of calculus. You could say, let capital F of x be antiderivative. Antiderivative of f of x. So therefore, the integral from a to a of f of x dx would equal antiderivative a minus antiderivative a. And what does that equal? 0. Yep, done. Okay, let's look at the next one. Just wipe the slate clean there. So 5b, it's saying, what about if we have some constant? Right, some constant. Okay, whoopsie diddle. So if you were finding the antiderivative of a constant, right, like here's a constant, 3. What's the antiderivative of that? It's 3x, yeah? Agree? Okay. You can check by taking 3x and differentiating. What's the derivative of 3x? It's 3, right? So, yep, I did my integral correctly. You could think of it using the idea of adding a power. So imagine that this is x to the power of 0. I add 1, and then I divide by 1, and I get 3x. Okay. So when you've got a number or a constant, your antiderivative, I mean, they've just called it k, right? So if you've just got k, it means your antiderivative would be kx. Okay? So let's use that. Might just write it over here. The antiderivative for 5b is kx. That means if I'm doing the integral from a to b of k dx, right, it equals kx, right, but my first x value is b, right, so I'll have kb minus k times a, right? So what I did there, you probably don't need to write, this might be a bit overkill. I'm doing antiderivative at b minus antiderivative at a, right, where the antiderivative is kx. Yep. Well, that's the same as this statement, taking k out as a common factor, and we're done. That's where they wanted us to go. Okay, so that one's nice and neat. All right, next one. Next one is C. We're going from B to A. Ooh, and A to B. That's kind of interesting. And they're saying that if you integrate from B to A, you get the negative compared to A to B, right? So, you know, imagine you've got a antiderivative. Just, I don't know, something simple. Do another curve. Right. Okay. And there's fundamental theorem of calculus is saying we can find areas under f of x. But I'm graphing antiderivative here. Right, so I've already found my antiderivative. And the way we find the areas, we'd have to go this one minus that one normally. And that would be here from A up to B. And I've just circled the wrong one, but it doesn't matter because it said the same thing. This one. What about if we did I'm getting myself in a muddle. I've just done this one, A to B, right? Well, what about from B to A, right? So effectively what we're saying is if we're going from A to B, right, it follows that we've got f of B minus f of A. But if we were going from B to A, right, it follows that we'd have capital F of A minus capital F of B. Yeah? And so what's going to end up happening is you're going to get negatives of each other. Like, let's say this one is, I know that's 2 and that's 4. Yeah? So in this one, you'd have 4 minus 2 equals 2. But if you reverse that subtraction, you're now going to have 2 minus 4 is minus 2. Yeah? So that's what it's going to look like graphically, I guess. And how could we show in a bit more formal manner, right? So you might want to actually start off by just saying, let f of x be antiderivative, right, of f of x, okay? And then we could say, well, on our left-hand side, which is this side of this equation here, all right, our integral from b to a, all right, I'll get it right this time, of f of x dx, that's going to be antiderivative of a minus antiderivative of b. Now, to do this elegantly, I want to be able to rearrange this a little bit to make it look like this one. All right? And I can see I need a negative, so let's rewrite this slightly. What if we put a negative in here? Now this would have to be negative, right? Because up there it's a positive number, right? I'm pulling this negative out of this expression. This would now have to be positive, yeah? Now, if I rewrite this ever so slightly, it's the same thing as this statement, isn't it? Capital F of B minus capital F of A. But what's this? What have I got in here? Right, that just that bit, ignore the negative sign for a minute. Just this bit in here is the integral from a to b of f of x dx. And we took a negative out of it. Let's put it back in, right? And now we've got this statement here. So we started there, and we showed the right-hand side with some manipulation there. Okay. Not sure if the next one will fit on the. I might have to go to grid paper, but we'll see how we go. All right, we're up to D. I might circle these in case anyone's needing to fast forward these videos. All right, so what do we got next? We've got like a constant that you can pull out of the integral. Right, but we have to show, right, we need to show that, so we have to do it formally. Okay, and I want to say a statement like, let f of x be antiderivative before I start f of x. Okay, and you could say, well, therefore, right, if you had k f of x, what would the antiderivative be? You might be thinking, oh, I reckon it's just this. Yeah? You might want to check that by differentiating, right? Like if I had some number, do a 3 again, right? So if my antiderivative equaled this, what would happen when I took the derivative to get back to my original f of x? Right? So the derivative of that, right, or the original function would be 6x, or, right, let's think about this one. If you had f of x, capital F of x equaled x squared, right, and you took the derivative of that, slash your original function, what would that equal? It would equal 2x, yeah? Now can you see that that's scaled up by 3 here, and this is also scaled up by 3? It's like this 6x, could have written it like this, 3 times the derivative of just the x squared, right? So we can indeed say that the antiderivative is k f of x, right? Which I'm going to use here. Right? So see if I can fit it on. I might need to write a bit smaller. We've got integral of a through to b of k f of x dx. We're saying that would be k capital F b minus k capital F a. All right, pull the k out as a common factor. And what are you left with inside of the larger brackets? You're left with the integral. So just looking at this part here, what's that? It's the integral of f of x, right? Without the k. Right, so the k's been pulled out of that, and we've showed that this statement here is true. As long as k is a constant, obviously. Okay, getting the idea here. One more to go. Now, in this one, I'll be smart this time, and I won't rub out the statement that I keep writing for every question. The only thing is that the next one has an f of x and a g of x, so let's also let capital G of x be the antiderivative of g of x. Okay, so let's go. We need to integrate all of f of x plus g of x. So that's going to look like this. It's going to look like, I'm getting ahead of myself, I've got to write this out, plus g of x dx. Okay, so this whole thing is together. We've got to put, the antiderivative with b's substituted in, all right, and we've got antiderivative of f of x is capital F, right, and of g of x is capital G, there it is. So the statement's going to look like capital F B plus capital G, all right, minus, excuse me, capital F A plus capital G A, okay. Excuse me. Now with just a smidgen of algebra here, we can do a bit of rearranging. Let's get our capital F's together. B, we've got a minus capital F of A there. Right, here we've got a plus G of B. Here we've got a minus plus, so we get that'll be minus capital G of A. Right, now I'm going to do something ever so slightly sneaky. I'll put some little brackets around that one and some brackets around this one, because what I'm trying to do is separate the two integrals. So this here is the integral of just the f of x. I had a look where I was going, right, before I started the problem. So this is, according to fundamental theorem of calculus, that's the integral of f of x plus, that's the integral of g of x. And booyah, that's all you need to do for that one, okay? All right, we'll stop the recording there.